Hello, Ms. Heller. Sorry about the delay on this video. I recorded it once, but some things did not transfer very well, so I'm going to do this real quick. But the full notes are already posted online if you need those, but I'll at least do a couple of examples on each one so you can get the basics of this. So 1.4, hopefully by now you've taken the quiz. If you haven't taken the quiz, 1.1 through 1.3, a few things to note: you can use your midpoint and distance formula. So you can go ahead and use the midpoint formula where you find the average of your x's divide and the average of your y's, which will give you the coordinates of your midpoint. Okay, remember you can also use those to find your endpoint if you know your midpoint and one of the endpoints, and then also to find the length by finding the difference, so the square root of the difference of your x's squared plus the difference of your y squared. You can use those on the quiz. And then I also reminded students that remember when you have a segment that's split in two different parts, that if you add them together, the two parts together, they equal the whole thing. And then anytime, remember, where they give you the midpoint, that those two tick marks mean that those two segments are equal. Okay, so you can use that in the quiz. Also, some students are having the pictures have a difficulty loading on the quiz, and I sent an announcement out on this on Canvas. If it's having a hard time loading, go ahead and exit out of there. Don't hit submit, but just exit out, and then it will let you resume. And every time somebody's done that, it's then loaded the pictures the second time around. So if you're having issues, that should resolve it. So after you get the quiz done, you should be working on 1.4. So 1.4 is about perimeter and area, and also reminding you that a polygon is a figure that lies in a plane. It has to be a closed figure. So by closed, I'm going to do some non-examples up here. A closed figure basically means it has to have this, so you can't just leave an open end there. It also cannot have any curved surfaces, so like a semicircle doesn't work. So basically all the segments have to connect. Each segment is considered a side of that polygon, and where the two segments meet are vertices. So in general, when you name a polygon, so any closed-sided figure is just polygon, and then you name all the vertices typically in alphabetical order. So like this one would be polygon A, B, C, D, E. Okay. We can classify different polygons by the number of sides. So if you have a three-sided figure, remember those are triangles. If you have a four-sided figure, there are lots of different four-sided figures, but in general terms, these are called quadrilaterals. A five-sided figure is a pentagon. 6 is hexagons. 7 is heptagons. 8, like a stop sign, are your octagon. 9 is nonagon. 10 are decagons. And 12 are dodecagons. Okay. If you notice, I already wrote 11 on there. It's the one I forget the most, is a hendecagon. And we don't use those very often. After you get past 12, although there are names for some of these, we typically will just say a 13agon, a 14agon, a 20agon when you get into the larger sizes. Okay. Besides being able to classify a polygon by the number of sides, you also need to know if it is convex or concave. So concave ones are ones that none of the sides, if we extend them, go on the interior of it, versus concave ones where if we extend this line, or maybe even if we extend this line, they start going on the interior. Those are your concave ones. Another term that you will hear with polygons, if something is a regular polygon, basically it just means all the sides are congruent. So like a square would be an example of a specific quadrilateral that has all the sides that are the same. Okay. So the first part of your assignment will be just recognizing those. So the biggest mistake that I see on these is just people not counting correctly. So just make sure that you're able to count the number of sides. So this one has 5 sides. So this would make this a pentagon. And if you notice, if we extended this line right here, it goes on the inside. So this would be concave. The next one has 8 sides, making it an octagon. And if we extend all these sides, none of them would extend inside, so this would make it convex. Whereas this one, if we count the sides, it also has 8 sides, which makes it an octagon. But it would be a concave one, because if we extend some of these, they go interior of it. And this last one, if we count, it has 12 sides, making it a dodecagon. And it happens to be a regular dodecagon because all the sides are the same, and it would be convex. The second part of this is taking 2 skills, one of which you learned earlier the week, and that is using the distance formula, and then something back with your basic perimeter and area of triangles, squares, and rectangles. In fact, on 1.3, one of the last problems had you find the perimeter of a triangle, and you had to use the distance formula to do this. Just remember, the distance formula from one endpoint to the other actually finds the length of the segment. So when we try to find the perimeter of a triangle, which is when you add up the length of each side, it's like finding the exterior of it, versus the interior or area would be 1/2 the base times the height. So for a square, remember all the sides are the same. So this is a regular quadrilateral. So we just have to take 4 times that. Could you add up the sides? Yes. It just simplifies it. And then area is side times side, so side squared. And then your rectangle, you have a length and you have 2 widths. So twice the length plus twice the width will give you the perimeter. You could also add them up. And the area is the length times the width. So I put a little reminder over here that perimeter has linear units because you're finding around a figure, and area has square units, which is really good. I knew that if I just gave you figures that were labeled, you could easily find those. So we're going to always take it a step further and combine this with your coordinate planes, which is what you were doing the other day. So we're going to have to find the perimeter and area of polygons. On the notes, notice I went ahead and put the coordinate planes on here. So the grid paper, when you go to do the ones in Big Ideas Math, I did put a PDF of some graph paper. So if you need to download that to use, you're more than welcome to. So we're going to go ahead and plot the points. So X is at 2, 4. Y is at 0, 2. -2, sorry. And Z is at 2, -2. So what we need to do to find the perimeter is we need to find the length of each side. So we're going to have to find the length of YZ. We're going to have to find the length of ZX. And we're going to have to find the length of XY. So the ones that are horizontal or vertical are fairly easy to find. We've been doing that. Remember, it's just the absolute value of the difference of the X values when you have a horizontal line and the absolute value of the Y values to find the vertical line. You could also probably just count if you want to, but at least for the first couple of examples, I'm going to remind you of where that number comes from. So the horizontal line, remember, finding the difference of these are just going to cancel out. So we need to find the absolute value of the difference of our X's, which would be the absolute value in this case of -2, which is just 2, because remember, length always has to be positive. We can do the same thing with our Y values when we're on a vertical one. So I can find the absolute value between -2 and 4. So the absolute value of -6 is just 6. And I'm going to go ahead and label these sides. But to find the length from or distance from X to Y, we're going to use our distance formula. So we're going to take the square root of 2 minus 0 squared plus the difference of our Y's. So 4 minus and -2 squared. So we get the square root of 2 squared plus 6 squared. So we get 4 plus 36, so the square root of 40. Since we are dealing with perimeter, we are going to have to find the square root of that. And if I remember right in Big Ideas Math, they're going to ask you to round it to the nearest hundredth. So in this case, I get 6.324. So if we look at the 4, that tells me the 2 is going to stay. So this is about 6.32. So if I wanted to find the perimeter, now that I know each of the sides, I just need to add all those together. So I get the perimeter is about 14.32 units, whatever it happens to be, feet, inches. And then our area, remember, is 1/2 our base. So we're going to consider YZ our base, which is 2. And our height in this case would be 6. So 1/2 2 times 6 would be 6 units squared. 6 is another triangle. We'll do one similar to that triangle on the next part. 7 is for a rectangle, and I think everybody okay on that. So we're going to try number 8. But there are examples, my completed notes, if you want to see what 6 and 7 look like. They are posted on Canvas. But just to do one that is a square. So D is at 5, -3. F is at, or E is at 5, -6. F is at 2, -6. And G is at 2, -3. So here again, if you recognize, I need to find the difference of each side. So 2 minus 5, that is -3. The absolute value of that is 3. So 2 minus 5 here again, so this side is 3. For here, we're using our y values. So the difference of these is 3. So we recognize that it's a square since all sides are the same. So the perimeter of a square, remember, is 4 times the side length. So we get 12 units. And the area is the side squared, which would make it 9 units squared. The rest of the problems on this are just going to take it just a step further with combining a couple pictures. Typically on these, if you do them in order, it will make it a little bit easier and will help you out on some of it. So here again, we basically have a picture where we have triangle ABD. We also have triangle CBD. And if we combine those, we have a quadrilateral ABCD. So the first thing they want us to do is find the perimeter of triangle ABD, so this top triangle. So we need to find the length of AB from B to D, and also from D to A. So remember the vertical and horizontal ones, we can easily look. So on this one, the difference from 4 to -1 is a difference of 5. The difference from B to D, so from 2 to -4, so 2 minus a -4 is 6. But from D to A, we are going to have to use our distance formula. So we're going to do the square root of -4 minus 2 squared plus the difference of our y's -1 minus 4 squared. So we're going to get the square root of -6 squared plus -5 squared. So we're going to get the square root of 36 plus 25. So we get the square root of 61. So if we put that into our calculator, that is about 7.81. So we can find the perimeter by adding all those together. So we get 18.81 units. Then they want us to find the perimeter of triangle BCD. Well, we already found from D to B in the top one, but we also have to find from B to C and from C to D. So if we go from B to C, we're going to use our distance formula. So the square root of 2 minus a negative 1 squared plus negative 1 minus a negative 5 squared. So we're going to get the square root of 3 squared plus 4 squared. So the square root of 9 plus 16 is the square root of 25, which is 5. And then we're going to do the same thing from C to D. So the square root of negative 1 minus negative 4 squared plus negative 5 minus negative 1 squared. So we get the square root of 3 squared plus negative 4 squared. So we get the square root of 9 plus 16. So this one also happens to be the square root of 25, which is 5. So we can find the perimeter of this one. So we do 6 plus 5 plus 5. So we get 16 units. So if we wanted to find the perimeter of quadrilateral A, B, C, D, we already have all the side lengths for this one. So we can add 5 plus 5 plus 5 plus 7.81. This is why it's going to be really important to go ahead and write down your work. So you can take a picture of it, number one, to submit. But also it might save you time if they give you multiple step ones like this. And then you're also going to be asked sometimes to find the area of those same shapes. So we already found all the different information we need up here to find the area of ABD. So we have its base and we have its height. So we can easily find the area as 1/2 the base, which is 6, times its height is 5. So we're going to get 15 square units. So if we find the area of BCD, well, we have a base, but we need to know the height. So the height is going to be straight down to the vertex. So if we think about this, this is a difference of 4. So to find the area here, we get to do 1/2 our base, which is 6, and our height, which is 4. So we get 12 units squared. So although there is a formula to finding the one for the shape, if we know the area of this triangle and we know the area of this triangle, kind of like the segment addition postulate, if we add these two triangles together, we can find the area of the entire shape. So for 14, we can really just find the area by taking 15 plus 12 to find out that it's 27 units. Okay. So really, and I made this one short. If you go into Big Ideas Math, I didn't give near the problems that we did, since a lot of this is just taking things that we already know and just applying it slightly differently. Plus, I know a lot of you held off until today to take the quiz, so I wanted to give you time without having too much work. So today, just make sure that you are kind of caught up. That's kind of the goal. Make sure you've completed, hopefully by now, 1-1 and 1-2 from last week, that you got 1-3 done. You from Wednesday this week, I had to think about that, the red day, that you take the quiz. The quiz isn't very long. Make sure you show your work. Only use the formulas. Don't be using all your notes. Just use the ones that I went over earlier. You can have those next to you. So if you need to screenshot that, you can. And then make sure you try to get 1-4 done. If you have questions, make sure you email or Canvas message, and I will be updating grades today.